Hello, beautiful people. Today we're going to be doing 8.5, and our SWABAT is the factor trinomials of the form x squared plus bx plus c. Our next lesson will have a coefficient here that's not 1, but today this is going to be just 1 for us, which is kind of nice. Nice little beginning for us. So you're supposed to do the warm-up first, and if you haven't, I'm sure you're probably frantically copying down my work right now, but most of you probably tried it already. So check your answers with mine. Factor out the GCF, the greatest, GCM, greatest common monomial. For number 1, we both had a 2 and an x in common, so we factored that out, and left over we had x plus 4 in parentheses. Just remember to check yourself. So 2x times x is 2x squared, 2x times 4 is 8x. If you don't get back to here once you're done, then you know you messed up somewhere. Number 2, they only had an a in common, so it's a times a plus 5. Number 3, negative 3s came out, so when your leading coefficient is negative, factor out a negative. So that again because it's important. When the leading coefficient is negative, factor out a negative. Left over was s plus 3 for that one. Number 4, we took out a 2x, and then left over was 2x minus 1. All right, let's get down to business. We're going to be factoring today, and we're going to be factoring trinomials. Now these trinomials, as we said in the beginning, the leading coefficient is going to be 1, which is nice, although on the next lesson, there's going to be a number here, but because you're going to learn this process, this is going to work every single time. If you have factored before, maybe you weren't super successful, I think this is kind of the most user-friendly way. This is the way that we do it in Algebra 1, but also in Algebra 2 and Algebra 2 Honors in this program. Works for everyone. If you've learned other methods and they work for you every single time, go ahead and do that. But if not, please, please, please just try this method and get with me on it. So first thing that we're going to do is draw your factor box, and I've already provided that for you. Just a 2 by 2 box. And then we will always, always, always put the first term in the first box and the last term in the last box. Again, first term, first box, last term, last box. That's always going to happen. You're going to hear me say it like a million times. If you want, you can keep a tally. See how many times I actually do it. But first term, first box, last term, last box. That's always going to be the thing. Now the question is, what's going to go into these diagonals? Well, here's how we get that. You're going to take these two numbers, the first and last term that you just put in here, and I want you to multiply them. We're going to times them. So k squared times 5 is 5k squared. And I'm going to think of two numbers that will multiply to give me 5k squared. But they also need to add to give me this middle term. Add to give me 6k. So you're thinking, what are two numbers that multiply to give you 5 and add to give you 6k? So here's what's happening in my mind. I'm thinking 1 times 5 is 5. 1 plus 5 is 6. So right there I have 1k and 5k. 1k times 5k gives me 5k squared. 1k plus 5k gives me 6k. So that's the way you're going to verify yourself. 1k goes in the one diagonal box, and then the 5k goes in the other. So this is what is known as a factor box. So we're going to factor now. Same way you did on the warm-up just a couple minutes ago. I'm looking at the first column. I'm looking at 5k and k squared and 5k. What do they both have in common? Well, there's not a number because it's just 1, but they both have a k in common, so I'm going to factor out a k. Then I'm looking at the next column, and was 1 and 5 have in common? Nothing really, just a 1. Notice I didn't put the 1 here because it's 1k. I don't need the 1 in front of that. And then I'm going to look from left to right. What do k squared and k have in common? What can I take out of both of these? I can take out a k from both of them. And then looking from left to right here, 5k and 5, I can take out a 5 from both of them. One note, no one cares if you put the 5k here and the k here. Still going to work out exactly the same way, except you'll have k plus 1 here and k plus 5 there. Same thing. Absolutely no one cares. So what is my result of this? This would be k plus 1, that's this part, times k plus 5. So when we're factoring a trinomial, we're breaking it down into two sets of parentheses, 2 different binomials here for us today. It's like unfoiling. But if you were thinking about like how you had to use, or how some of us used a box to multiply, instead we're using a box to factor. Not quite divide, but to factor. Like if we're factoring 6, the number 6, we're breaking it down to 2 times 3. Okay. Let's try part B. What's the first thing that we're going to do? First thing, beautiful people, is still first term in the first box. Last term into the last box. First term, first box, last term, last box. Always. Now we're going to multiply and add. I need two numbers that will multiply to give me this product. So x squared times negative 8 is negative 8x squared. This is always going to happen. You're going to multiply these. And then you want them to add to give you negative 2x. That's what we're thinking about in our heads. And so what we're doing here, I wonder if this will show up. You're just going to go through a list of factors, but it needs to multiply to give you negative 8x squared. Negative 8x squared. So that means one of the factors has to be positive and one of your factors has to be negative. What does that look like? So let's go through the process in our head. I know negative 8 times 1 gives me negative 8x squared, but if I add those together, I get negative 7. That fails. So we try another one. Let's try, what else gives you 8 to multiply? 4 times 2. Let's try negative 4 times positive 2. Negative 4 times positive 2 is negative 8. Negative 4 plus 2 is negative 2. So that works great. So I'm thinking negative 4x and positive 2x. If I multiply them, I get negative 8x squared. And if I add them, I get negative 2x. So that's going to go on my diagonals. There you go. This one, it does matter. If I had written negative 2 times 4, I do get negative 8. But what do I get when I add them? Positive 2. So that would tell me, oh, I got to switch the signs. Okay, so now let's try to factor using our factor box. It doesn't matter which way you go first, either left to right or up and down. Up and down first for me. I don't know why. X squared and 2x, they don't have a number in common, but they do have an x. So I'm going to factor that out of these two. Then I'm looking at the next column. Negative 4x and negative 8. They both have a negative 4 in common. Now let me talk to you about this sign really quickly. You're always going to take the sign that's closer to the edge. So because this is negative, this will be negative. Because looking at this one, closest to the edge here is a positive number, so I'm going to take out a positive x for that. Now I'm going to go from left to right. I have x squared and negative 4x. They don't have a number in common, but they do both have an x term. So I'm going to factor out an x for that one. And then as I'm looking from left to right here, the question I'm asking myself, ooh, should I make this positive or should I make this negative? Because there's a big old negative right there. However, no one cares about this now because I'm going for closest to the edge. Closest to the edge is a positive, so this will be positive. Closest to the edge for this one is a positive number, so this will be positive. Positive what? What goes into 2x and negative 8? 2. So you have x minus 4 and x plus 2. Very good. Okay, some of you are like, okay, that was slow and I get it. Go ahead and go solo and try this right now. You can go ahead and press pause and then you can press fast forward when you're done. But for those of you that are still a little bit risky, first thing that you know is to put your first term in your first box and your last term in your last box. So go ahead and do that. And now you're looking for two numbers that will multiply, just kidding, multiply to give you this product. So k squared times 12 is 12k squared, and that will add to give you the middle term. So then in your head, you're going through a list of factors, and I'm only writing these down so that you can see what's in my head and hopefully not get too frightened while you're in there. So numbers that multiply to give me 12. Well, in my mind, I'm thinking 1 times 12. 1 times 12 is not 7. I'm sorry, 1 times 12 is 12. but 1 plus 12 is not 7. And then I'm thinking, okay, 2 times 6, that's 8, not 7. And then I'm thinking, okay, 3 times 4. 3 plus 4 does give me 7, so I think I have a winner. 3k times 4k. 3k times 4k is 12k squared. 3k plus 7k, I'm sorry, plus 4k is 7k. So those work. Notice here, like, I'm just double checking myself to make sure I'm good. Okay, now if you could please go ahead, press pause and factor using your factor box if you feel pretty good about it. But I'm looking at these and I know they have a k. These two have a 3 left to right here. They both have just a k. And these two have a 4 in common. That's the biggest number for each of them. So in factored form, this will be k plus 3 times k plus 4. And again, no one cares what the order is. If you put k plus 4 times k plus 3, I don't care. As long as you have the right numbers in the right spots and the right signs, we're golden. Alright, so try this one on your own, like legit, press pause. Alright, check yourself with my work. I got x plus 3 times x plus 5, and then again, if you wrote x plus 5 times x plus 3, same thing, no one cares. Alright, that's that lesson. For our next class, or our next video, you're going to have a number in front of here. So when you're multiplying them, you'll have something that's not just this times this. It'll be like this times another number, and then we'll just take it up as, say, one notch, just one notch, but not difficult still. Thank you so much. I'm going to stop rambling. Have a great day.